Welcome to the third segment in our series of statistical experimental design vignettes. So far, you have been introduced to the philosophy of experimental design and have learned why balanced factorial design configurations are superior to the one factor at a time configurations. The next aspect of designing successful experiments involves more than just the statistical approaches and delves into the field of management and organizational interaction. This is part of design of experiments that is often neglected in ordinary textbooks and classes. However, it is one of the most important aspects of successful experimentation. Watch as you will learn that you already have a lot to offer to experimental design, which is the focusing tool of your prior knowledge. Let's look at organization for experimentation. Inadequate organization is the greatest source of failure in designed experiments. And reliance on computer software that is purported to do it all. You still have to think and apply your good prior knowledge. So what do we do? Before any experiments see the light of day, we assemble a team, brainstorm, elevate the critical factors, and use some simple statistics to focus this information. We have 2 meetings. The first is only an hour long, and it's when we brainstorm. I recommend doing this on a Tuesday when the thoughts of the weekend are a bit more distant, but not so late in the week that we don't have time to hold the second meeting, which should not be on the same day, but a day or 2 later. Hold this first meeting early when your minds are sharp. The first 10 minutes are introductions and a statement of the problem being worked on. I am always surprised how fast brainstorming goes. 20 minutes and our brains are drained. The factor type identification takes the remainder of the meeting. We'll see more detail a little later. There are 4 essential players on the team: the experts, the semi-experts, the operators, and the customers. We'll see why all of them are necessary in a moment. The experts have the responsibility for the entire project. They usually think they know the answer. However, another expert who's not working on this particular project may be able to ask questions that will strip away the blinders the experts often have as they look at a solution with tunnel vision. This expands the opportunities for an even better solution. By having the operators, who will probably be doing the actual runs of the experiment, we have their insights that those of us flying our desks often lack. Plus, by having the operators on board during the planning, we give them ownership and understanding of the strange runs we will be making. That way, they are not tempted to make corrections to the experimental runs, and in doing so, ruin the experiment. The customer is the next in line, the person or entity or subsystem that gets the output of this experiment. These are the ones who know the correct response variable. Again, by including the customer, we give the customer ownership of the experiment, and we will have an easier time selling them the results. Including operators and customers is good psychology. You have probably done brainstorming before. Recall the tools are flip chart paper, marking pens, and tape to attach the completed pages to the wall for all to see. Displaying the previous ideas catalyzes new thoughts. Write big so all can see. Later, we'll indicate the type of factors with the colored markers. Be sure the team covers controlling factors, the ones you usually think of that you have control over and can set by design. However, They're outside of your control noise factors. Don't bury your head in the sand and neglect them. Often you will need to investigate how to make your design robust to these noise factors. To do so, you must include them in the experiment. The last category of factor is the response, the thing that changes as a result of your manipulations. Usually, there is more than one response, and you need to consider all responses. I have seen experiments that only included the primary response, which was optimized, but to the detriment of other responses. Often, we need to find a trade-off between multiple responses. Capture only 10 items per page and write big. Display the pages for all to see. This acts as a catalyst for new ideas. After the first brainstorming meeting, the ideas are compiled and sorted into each of 3 types. A form with the names of the factors and a place for each member to vote is sent out immediately. Now the team members can work with their thoughts regarding the ratings of the importance of the factors. Use a scale from 1, low, to 5, high. An Excel spreadsheet is a good tool to compile this communication to all and can be sent by email to the team members. No more than 2 days after the brainstorming meeting, we will schedule the follow-up meeting. This is much longer, since there is much to be done. We review the goals and then review the previous brainstorming effort. We ask if there are any additions. We purge ridiculous ideas like phase of the moon. We find redundancies and consolidate similar ideas like moisture and humidity. Using the Excel spreadsheet speeds up the calculations of the mean and standard deviations of the votes of the team. Using a scale of 1 to 5, a standard deviation greater than 1.33 indicates a lack of consensus among the team members. The team will need to discuss such conflicts. Votes can be changed until the standard deviation is below 1.33. See how a simple statistic, the standard deviation, helps in consensus building. Selecting the factors is easy after the consensus has been achieved. Just pick the highest average ratings. How many factors depends on our resources, but I recommend no fewer than 5, but no more than 9. Next, we need to identify the levels of the factors. This may even require some lab bench tests to get the realistic levels. Don't be too flamboyant or too shy in setting the levels. Here's an example of levels for 2 factors from an experiment involving dimensions of an assembly. In the spirit of bringing in as much prior information, we will attempt to determine possible interactions. Here's a system I have developed to help the team focus their prior knowledge even if they do not know what an interaction is. To use this method, first draw an XY axis and label the Y the response and the X one of the factors. Now, lay a pen on the origin and ask the team what they think the change in the response will be. Say, as in this example, the temperature increases from low to high while the second factor is at its low level. Move the pen upward according to their suggestions and give it a slope they agree upon. This is not meant to be exact, but only qualitative in accuracy. When there is agreement, draw a line and move the pen back to the origin. Now have the team guess what the slope and upward movement would be for the high level of the other factor. If the slopes differ, then there is an interaction indicated. If the slopes are the same, then there is no interaction. The greater the difference in slopes, the stronger the interaction. Of course, this is merely a guess, and the experiment will confirm and, more importantly, quantify the degree of the interaction. I have heard some engineers say, "We know the interaction, why bother to experiment?" The answer is, we only know qualitatively, The experiment will quantify this function. So, the 4-hour meeting has elevated the factors, set the levels of these factors, and identified the possible interactions. All that's left is to review the action items and assign the timetable. The 2 meetings that form the organization for experimentation are the most valuable meetings you will ever attend. The material we have discussed in this vignette is covered in Chapter 2 of my Quality by Experimental Design book. There are, of course, more details there than I can offer in this short introduction. In our next vignette, we'll look at how to construct balanced factorial designs. See you then!